Thank you very much for inviting us here on stage to present our work, which has the name Defying Gravity. We all know that there is the human need to see beyond his senses. For example, if we would like to see something very, very small, we would use a microscope. If we would like to see something that is far away, we can use a telescope. But what about if we would like to see an object that is moving too fast for our eyes? We all know that the human eye has specific limitations. So then we can use a stroboscope. The strobo light consists of flashes of light, repeated flashes of light, that enable us to catch frames and to see things that we could not otherwise see. In this case, we use the stroboscopic effect so as to, in a different context, to study the free fall of water droplets. And that's why we have this black chamber, and George will give us a brief description of this chamber. So George...
Okay. So we wanted to make droplets to fall with a specific frequency of 50 Hz. 50 Hz means 50 droplets per second. Okay, in order to do this, we use a speaker, which is here, if the camera can come closer, okay? And we attach the end of the water tube on the speaker. So the speaker now makes a sound of 50 Hz, as you can hear, okay? And so each time it vibrates, it moves the water tube and the droplet falls, okay? And we have also LED strips, two on the left and two on the right, and we change their frequency with this application. So now, okay, now the LEDs are always on, and we see a constant flow of water. But if we reduce the duty cycle, then the droplets appear, and you should see the beautiful spherical shape that they have. And now the frequency of the LED strips is 49 Hz. Remember that the frequency of the sound is 50 Hz. And now we see the droplets to fall slowly. If we increase a little bit the frequency of the LEDs, and now it's 50 Hz, we see that the droplets seem motionless still. Now I would like one person to come here, if it's possible. Come on. Okay, thank you.
So, thank you. Your name?
François.
Okay, and you are from?
Belgium.
Belgium, okay. And we will give you this cup. Okay. So,
We increase a little bit the frequency to 51 Hz, and now you will see the droplets to move upwards. Is like they defy gravity. And I would like to put your cup inside the chamber. And great. Although the droplets go upwards, the cup fills. Thank you very much. And we can play a little bit with colors. We can add some colors to this experiment. Now the flashes make two colors. Okay, red and white. They have the same frequency, 51 Hz, but they have a small time delay. That's why we can see the droplets with those two colors, and we can have also three or three colors. Each droplet has its own color.
Okay. I would like to add this point that we have made a digital repository for all users that we would like to implement this in the classroom, and it contains every need, theoretical background, instructions, setup instructions, simulations, worksheets, videos, topics that you will need in order to do the same thing with your students. Thank you very much for your attention.
Thank you.
George and Kelly, thank you very much. I mean, that's a magical operation you've got going there. So, what sort of, tell me a bit about your students' reaction to this when you actually showed it for the first time.
They were actually enthusiastic, and that's very important to keep our students and this enthusiasm. So the first thing is this enthusiasm. And then the second thing is because they were eager to know the explanation. So they were eager to learn, and that's really important. And actually they studied, they actually calculated the acceleration of the gravity using this device. When they are still, they use the ruler, they use the equations, and they also use physics, and they realize that behind the illusion, actually there are basic principles of physics. We can explain everything.
Fantastic.
Yes.
And are they already, do they have suggestions on how we can convert this machine into something that can defy maybe gravity of me or other liquids?
Not yet, but I hope that they will find something. Okay.
Next science and space, perhaps.
That sounds good. Okay, well, George and Kelly, thank you very much for your demonstration.
Thank you.
And all the best going forward and the way to use this to connect the two. Thank you very much. Okay, so moving on to our second group, who are from Belgium. By the way, George and Kelly, you can find at stand T1. So if you want to have another go as you see the demonstration of gravity-defying water droplets, then please go visit at T1. Nearby, actually, at stage T35, is a group from Belgium who are now coming to the stage. Elias, Rudolf, and Raphael, welcome. And your experiment is entitled Understanding Radioactivity. And by the looks of it, you've got a cloud chamber there. So I'm going to pass over to you guys, and you can explain to us all about your experiment. Good luck.
Okay. So when hearing about radioactivity, most people will think about huge explosion or some frightening mutation like a fish with 3 legs and 4 arms. But radioactivity is not always dangerous, and it's part of our lives. And for instance, just beneath you, there are some radioactive elements that helps the Earth to stay warm. And in the air we breathe, there are some radon, which is radioactive gas, but it's in trace amounts, so don't worry too much about that. And if you would like to avoid some radiation, maybe by taking a balloon up to the atmosphere, actually it's even worse, because of particles coming from space that are eating molecules up in the atmosphere, causing a chain reaction of particle decays, and the shower particle reach the Earth. But you don't have to take my word on that. As a real scientist, we will prove that, and with this device we will be able to see that. So it is a cloud chamber, and okay, it's already working. Maybe we can have a look. Okay, but we have to come closer, or maybe put the video on to see what's happening inside. So here, it's a video of what happens inside here. So as you can see, there is a metallic rod inside. It contains some thorium. And did you see that? there are some particles that are emitted from the radioactive element, and we can see it with our eyes. And I find it really wonderful, and each traces has different shapes, lengths, curves, and depending on their characteristics, you can determine which kind of particles it is. And for the little story, it was used by Anderson, and he discovered the positron with that. And he was awarded the Nobel Prize for this discovery, and how useful it was to discover new particles beyond extending or understanding of the universe, you may ask. Have you ever heard about PET scan? It's a medical device that uses positrons to see the metabolism inside the bodies. And in fact, the P in PET scan is for positrons, the particle that was detected in a cloud chamber just like this one.
All these tracks appearing out of nowhere, it looks like magic strike. But in fact, it's even more interesting than magic. It's physics. And contrary to magician, physicists reveals their tricks. So all this whole mess works. So despite the very complex appearance of this device, a cloud chamber is pretty simple in its working principles. So, and it's constituted of two main elements that are locked into a waterproof enclosure. So, at the top of the chamber, you have a spongy medium soaked with alcohol. And at the bottom of the chamber, you have like a metal plate that is cooled at very, very low temperatures, like minus 20 or minus 30 degrees Celsius. And at the top of the chamber, we are at room temperature, so roughly 27 degrees Celsius. At this temperature, the alcohol, which is a very volatile chemical, evaporates into the chamber and falls down to the cold plate. And this is here where the beautiful physics takes place. During this fall, the alcohol is cooled down very, very rapidly. And normally, at low temperatures, alcohol just jump into liquids, right? But here, something different happens, something crazy. The cooling is so fast that the alcohol vapor doesn't have the time to turn into liquid. So it just stays here at metastable, pseudo-stable gaseous states, and it just have to have a particle to, it just wait to have a particle to pass through to condensate. So you can see a lot of particles in there. So yes.
Wonderful, isn't it? So we have the great news for all of you. We have made a guide that will help other students and teachers to build a cloud chamber by yourself. The guide will be available for all kinds of budgets. Some cloud chamber use dry ice, others only need electricity. And just take a couple of seconds to think about your next classes if you could bring that type of device. How wonderful would it be for students to see particles from space? And you could talk about radioactivity, just like we did, about cloud formation. After all, it's just a cloud chamber, or even medicine and biology, just like I did with the PET scan. So if you, because honestly there are a lot more to talk about, but if you need further information, please be welcome to our stand. It will be the T35, and we are here during the afternoon. So thank you.
Thank you very much indeed for your display. It's fascinating to see a cloud chamber in real life. So tell me, where have you seen the greatest intensity of these sort of trails of alcohol vapor? Where have you seen the most particles whizzing through?
So it was the best place to see particles has to be in a cold environment, maybe in your garden, or if you have the chance to go above in the atmosphere, maybe taking a balloon, it will be even crazier than that.
I was about to say, the higher up you go, the better, but in Belgium there's not too many mountains there, so have you gone to France, neighbouring France, to the Alps to see what happens?
We didn't that yet, but we will do that.
Well, you can actually get in contact with this teacher exchange program.
Yeah.
Pick a country that has high mountains and think of a way to get your cloud chamber there.
Oh, it will be wonderful. Thanks for the idea.
Not at all. But positrons, surely positrons, as soon as a positron hits an electron, you annihilate and you form two photons.
Exactly.
So your cloud chamber, you couldn't see it. Well, can you see the photons?
Actually, no, the photons you can see it, but the positron you can see it because sometimes it only collides with without annihilating, because it's all about probabilities.
Yes.
But Anderson, the physicist who won the Nobel Prize for discovering the positron, see them through a cloud chamber.
Fantastic. Well, gentlemen, thank you very much indeed. Good luck and enjoy the observations of all particles in the cloud chamber. Thank you. Right, before we move on to another highlight, I'm going to take the time to have a quick chat with a new friend, Mr. Adrian Allan. Can I ask you to come onto stage and join me, Adrian? Now, Adrian's from the UK, and Adrian is heavily involved with the Science on Stage webinars. So these are an opportunity to spread. Come into the light, so you're well seen, Adrian. And the idea about the webinars is to spread the ideas that are formulated and initiated here at Science on Stage. And the webinars are entitled From Teachers for Teachers, if I'm not mistaken. Adrian, tell us a bit about these webinars and perhaps how others can get involved.
Sure. I've presented 4 webinars so far. The first one was initiated by David Feeding, who a lot of you will know, and a lot of you will miss because he wasn't able to turn up to this conference. So we, Paul, and from Ireland, and David, put together a magic webinar, and the 3 of us presented magic demonstrations with a scientific basis. We did 2 more after that. What was nice was by the time we got to the 3rd one, there was about 6 or 7 people from all around Europe presenting. We had Ruth Oliveira from Portugal, Miriam Munoz-Molina from Spain, we had Michael Gregory from France, and Takis Lazos from Greece. So it became a truly European sharing of ideas in a live webinar. After we did the first webinar, there was also something called Bob Worley. There's a lot going on in the group chat during these webinars, and people are making contacts and sharing ideas and collaboration. So Bob Worley, who was interested in microscope chemistry, said, we can do this online teaching and having to do experiments in a visualizer live to pupils during the pandemic, we should share our ideas. So we did a recorded webinar on microscale chemistry, which is on the Science on Stage website. So if you're interested in hosting a webinar, get together and contact Science on Stage. Danielle Newman, who is fantastic at hosting these, and she will be quite flexible about how you want to do the webinar. If you want to do it live, that's great. But some maybe are not confident talking, you could pre-record it, or you could have a camera going down and show what you're doing. Takis Lazos agrees to alter music by video as well. So there's lots of options, and what's nice about the webinars is looking at the group chat and the feed and the sharing of ideas and the collaborations that are occurring.
Well, thank you very much, Adrian. So, just one more time, please repeat. So, how anybody who wants to join in the fun and produce a webinar, who do they contact?
They would email Science on Stage. Daniela might be able to keep it right, but I think if you email the Science on Stage and go to the website, I think that there may be a link interesting hosting a webinar. But normally they'll put you in touch with somebody who can allow you to provide a platform to share your ideas.
So check out webinars, email Science on Stage, and please, do it. You can add some content, that'd be fantastic. Adrian, thank you very much indeed, and all the best in all your future webinars.
Thank you.
Thank you very much. Coming on stage, they say that if it moves, it's biology. If it doesn't work, it's physics. And if it smells, it's chemistry. And I can already sense a few nice and pleasant and familiar odours, because indeed I'm a chemist myself. And it's a pleasure of mine to introduce fellow chemist, Mark, and the lovely Sabina. If you'd like to come onto stage, I can see that we're protecting the carpets here at Clarion Congress Hotel, so it looks like it's going to be some fun. So Mark and Sabina are from the Netherlands, and yeah, and you want to definitely go. If you haven't been to their stand, I can thoroughly recommend that you do so. It's D10 in the room next door to the left, and their experiments are entitled Baffling Chemistry. So I'm looking forward to be baffled, Sabina.
Does this work? You can hear me? Okay. Thanks for having us. Here is Mark. Mark will show some really nice chemistry. He will do something about rocket fuel. Well, who doesn't want to see that rocket fuel? But before we do that, I will show you a little experiment that you've probably seen already. I have here some hydrogen peroxide. It looks like water, but it isn't. H2O2. And I will pour something in here. And hydrogen peroxide decomposes when it's getting into the light we want, but very slowly. So to speed things up, we need something. We need a catalyst. A catalyst will rapidly go, how do you say it?
Speed up the experiment.
Speed up the reaction. So I have a little bit of manganese oxide, and I will put it here. And then hopefully the peroxide will decompose more rapidly. And when it decomposes, it will generate oxygen. So here I have a burning wood chip. I will just put it here. Then the catalyst goes in. We see the reaction going. And now the glowing wood chip goes in. And it burns again. I will do it once more. And it burns again. One more. So now you've seen it generates oxygen. And remember the word catalyst, because it's important for the rocket fuel.
Thank you. During World War II, the Germans built a V2 rocket, and the V2 rocket, they have used alcohol as a fuel for the rocket, because normally they would choose for a fossil fuel, but all the tanks and the jeeps were driving on that fossil fuel. There was a lack of fuel, so they decided to try alcohol. So they fermented potatoes, and it releases alcohol, and they use the alcohol for their rockets. So I did bring alcohol. It's 69% alcohol. It should burn. Normally alcohol burns at percentage of 40% and higher. A little bit more. Oh, chemist, come on. Sarina showed that hydrogen peroxide delivers oxygen. So they filled the rocket with hydrogen peroxide, and in the motor they mixed it with the alcohol. So I will mix it here, and I think I now made rocket fuel. For me, this is the most caring part. Thank you. So I will. Can the lights out? Is that possible? Can the lights go out?
Yeah, we can.
Thank you. Something is missing, I think. This is the game that I play with my students. That's not too much. I cannot find my. Oh, wait. I have a. Yeah, this one. Thank you. You can shut up. So I speak with my students about what is missing, and they have seen the experiment before. So I hope they will say the catalyst is missing. I'm using potassium permanganate as a catalyst. In the rocket fuel was used sodium permanganate. Let's see if this works. It works. So, this was our rocket fuel experiment. We're finished.
You finished?
Yeah.
Oh, okay.
We have 7 minutes.
Right, yeah, well, thank you very much. I quite like the idea of, you explain how it's the V2 rocket, the German army. I can just imagine, the German high command during World War II shouting down the telephone to the German scientists, we need a new Wunderwaffe. And they, of course, the German scientists go away. What do they come up with? Alcohol. So alcohol saved the day, or not for London though, but it did a good job for the rocket fuels. Well, tell me a bit about, this is an experiment with rocket fuel.
Mm-hmm.
So have you had any mishaps along the way? Tell us about any stories where you've been in a school classroom environment where the rocket really has delivered a surprise?
In this classroom.
I think that the best science lessons are lessons where things go wrong. Because children will remember that. And children will speak about that, what happened in your classroom. What they also will remember are context. So I can show this reaction, putting alcohol, hydrogen peroxide, catalyst, flames, and then I don't think that children learn from that. I think children have to learn from the context. So that's why I use the rocket fuel. About things that went wrong, yeah, I used too much potassium permanganate. So the flames went that high that my ceiling is black. Sometimes, that's why we used the blanket. Sometimes it goes bang and then it goes like this and like that. Very spectacular, very much fun. So yes, sometimes things go wrong, even with this experiment.
And what happens if you change the alcohol? Let's say if you use either you go down a step to methanol or up a step to propanol.
I didn't try that. I think next year I will be back here and then probably I demonstrate your proposal.
Okay, fantastic. Well, Marcus, I mean, a round of applause, please. Thank you very much for showing. Okay, before we come to our grand finale, it's a pleasure of mine to ask on stage to join me another friend of Science on Stage, and that is Astrinos from Greece. If I can ask Astrinos to join me up here. And Astrinos is involved in the development of teaching materials for the Science on Stage webpage. We thank you very much for that. And you can, indeed, if you go to the website, you can find all sorts of interesting and useful material, coding in STM, language skills for primary schools, and many others. So, Astrinos, welcome, and tell us a bit more, let me pass you the microphone. Tell us a bit about what you're doing, what you're creating for Science on Stage.
Yes, just a few years ago, I was very excited to take part in the creation of a brochure called Coding in STEM Education, which involved a lot of microcontrollers into our science teaching. But what made me so excited was that I had been using the Science on Stage Europe materials for very long before that, and there was something about football in our science teaching, language skills, and everything. So, everything was ready and available for us to use, like worksheets and all the needed material. My unit was about, it was called Rolling Sound, and it was in fundamental science and how to calculate, how to measure rotational speed by using the Doppler effect. Just a microphone, a mobile phone, and a freeware program like Audacity, nothing more. And of course, the layout was so spectacular. I didn't expect, I didn't believe it. I tried to find who the author was, because the graphic designers are so good. You cannot imagine. So what I strongly imagine is go to the website, download the material, use it in your classroom, and apply for the next project in autumn. Everything is like you are living a new mini festival. That's all.
Well, thank you very much for offering that. So everybody's free and welcome to go to the website, download the material, and use it as they will.
Yes, for sure. And participate in upcoming projects.
And that means it's possible to help you generate further downloadable content?
Yes.
Okay, great. So you've got your point right here, and so there's plenty of opportunity. They can get through the website and contact you through there, right? Excellent. Well, thank you very much. Thank you very much.
Thank you.
Thank you. Right. Well, so we come to the climax of our second highlights, and indeed, the gentleman who's going to come on stage now is somewhat of a polymath. He's not only very good at science and physics and explaining how the motion of all sorts of objects physically happens in an accurate scientific manner, but he also has the charisma, I think, of a Shakespearean thespian and an actor, as well as quite the genius with all things with a rotational velocity, and we saw yesterday one of his performances, which was quite fantastic. So by popular demand, it's my great pleasure to welcome back on stage Mr. Federico Benuzzi.
Yeah.
So please come on stage. From of course, from Italy. And this will be another, you're at stand A8, so you can meet Federico and speak to him at stand A8. He's got, this is another, I suppose, an episode from your Dreamy Physics.
Yes. This is the first part of the lesson, the show. I don't know how can you define Dreamy Physics. It's difficult.
Fantastic. Well, ladies and gentlemen, please, enjoy yourselves by watching another fantastic performance from Federico. So the floor's yours.
Thanks. So, hi. Today, I want to speak about cigar boxes, which is strange stuff. One of the most popular tricks is this one, but one of the easiest is this. So, okay. And first of all, do you know what they're made of? Oh, it's easy. I can tell you. Listen. Wood. Not my head. So, but the very interesting thing is another one. Do you know what this black thing is? This one? Oh, a magnet. Who said that? No, you silly, it's not a magnet. If it were, there would be a trick. On the contrary, here, if you don't push, they fall down. So, silly him, silly too, because I was sure that were a magnet, but here, you don't push. So, sorry for the magnet joke, but I had to play it because otherwise kids, during the show, go like, there's a magnet, I hate you! And it's just a kid, alright, but nannies, daddies, uncles, grannies, one daughter now is based on a true story. Hey, 90-year-old Bulgarian it's like, hey, fan ban fata. For non-Bulgarian speaker, let me see. Kožerila. For non-Bulgarian speaker, what is that? C'è carabinita. For non-Bulgarian speaker, there's a magnet. No, madam, there's no magnet. If you know, magnet attract on the ball, but repel on the other ball. We all played with German when we were kids. You know the toys, but she is 90 years old. Maybe she went through the First and the Second World War, so maybe she doesn't know what German is, and in fact, she stares at me. Is there any Velcro? For those who know what Velcro is, it's those for the fastening tape or to Tuesday. So, no, madam, there's no Velcro. If it were, how to do this? They would stick together. But she stares at me. Is there a special glue? Special glue? Sorry, madam. If it were, how could I do this? The left one and the middle one would attach that because I turn it off with my hand. But what about the right one and the middle one? They should still stick together. But she stares at me. Is there a button? A button? Where would it be? In the handle. Which one? All 8? According to the old lady, every and each of these stuffs has 8 buttons, and buttons must be small because the audience can see them, but not too small because you can't look for them while you're training or performing. And must be responsive because you can't push as hard as you can to make it work, but not too responsive because if you might touch them, cigarette boxes, they touch. So people, please, if you ask a question, please, you have to do and think that Italy is archaic. Weird how also the word archaic is archaic. However, the action I propose to you is to think. If you ask a question, hold on a sec, count 10, and if you don't know answer, please think again. In this period, I'm already mad at people who go on TV only to talk about this and that. Do you know what I mean? Italian television is full of this kind of people. I imagine myself meeting one of these mythological characters. Good evening. Good evening. What do you do for a living? Oh, they just call me only on TV, only to hear what I have to say. Really? What about? Oh, everything. I comment about this and that. Really? And you get paid? Oh, sure. A lot. Wow. The last question, sorry, but did you get paid? And okay, but did you go to school to be good at what you're doing? No! You also notice there's something wrong about it? Or is it just my opinion? However, stop complaining and back to business. I have 3 steps in my hand. Left and right, don't fall down because I'm in my hand, but hold down the middle one, subject to the gravity force. That force which attracts all objects one to each other. Why doesn't fall down? Friction, the great unknown. Friction is that force which prevents material from sliding against each other. An example before going on. In winter, when you go out without wearing any gloves, I know you do it, is the same kind of people who go out with flooded out trousers without socks in winter, you know? So you are walking, and it's so cold that your fingers are crumbling. What do? Rather than admitting that the mama was right, man is always right. You start to rubbing your hands together. The cause of heating generated by rubbing is called by physicists friction. Another example, you want to play a joke to your teacher, so you drag the teacher desk on the opposite. Have you ever done it? It's funny. You can place the teacher desk on the opposite side of the classroom. Then you turn or the student desk on the other way around. When teacher gets in, he or she go like, because there's the classroom and so. However, the effort you make to drag the desk is called by physicists friction. The problem is that physicists are very uncommon people. I know because I have one of them. They don't simply name things. Ciao Ben, I name you friction. No, they wonder about everything. Magic mirror on the wall. What does friction depend on? Physicists conduct experiments. For example, take a chair. And thank you very much. So, take a chair, place the chair on your stage, and drop it. Then, take your father, put your father on the chair, and drag it again. When your effort is bigger, friction depends on micro-weldings between surfaces in contact. The more you push, the more micro-welding increase in quantity and depth. Also became more difficult to break them. The pressing force. Friction depends on pressing force. And addressing to minors. If your mother asks you to move a piece of furniture, there are two things to do. First of all, you must report her for exploitation of child labor. If lawyer knows what to do, probably your mother will be financing you forever. But if you want to have dinner tonight, you must empty it. Because if the weight decreases, the pressing forward decreases, then there are less micro-weldings, and then you can easier drag it. So I see some faces of exploited children saying, yes, I know, I have already understood it, even without studying physics, but I don't want to teach you nothing. I'm here to instructor learn it. So, but friction depends on something more. You are at home, at the third floor, and your best friend calls you to go out together to put firecrackers into mailboxes. Have you ever done it? It's fine. So you run down the stairs, and you are so excited that you jump over the last 6 steps. Why are you flying? Remember that your mother on Saturday is used to wax the floor. Done! While you're still flying, it seems a Japanese cartoon. The jump is 3 episodes long. You also see the horizon of your home, or whatever. So, while you're flying, do you prefer to wear a rubber sole shoes or leather sole shoes? Sure, rubber is more fun. Sorry, leather. My rubber can save your life. Materials. Different kind of material offer different kinds of friction. I could have done this trick also with wooden surfaces. It's not a problem. But in Bologna, we say that wood is spliski. For non-Bolognese speaker, it's light. In physical terms, we say that it has a low coefficient of friction. This is velvet. Velvet is soft, so it absorbs the impact, but above all, it has a good coefficient of friction in physical terms. It doesn't slide in English, and splays gamea in Bolognese language. But if you tilt it so much, and sorry, but the time is not enough, I have to stop. This is the beginning of Dreamy Physics. Dreamy Physics is 1 hour long. There's some explanations, some performing. The goal is to explain physics through the juggling, and the juggling through the physics. You know, when physics is applied to something real, it gets closer. While juggling through the scientific eyes reveals its secrets. And the secret of secret boxes are those. absolutely amazing, Federico Beruzzi. I am too old for that. It's not coming through.
That's quite a wonderful performance. Very much. I suppose watching that, I like the idea of gravity and then the friction. But in many ways, friction is the electromagnetic force, right?
Yes, sure.
The attractions of electrons and positives and negatives. I love it very much. Great stuff. And can I ask? Are you trained as an actor or
Yes,
as well?
Yes, a lot. I'm training a lot as an actor, as a juggler, as a teacher. So I study a lot. I perform a lot. I train 1 or 2 hours all days at home. So
Yeah, lovely.
it's
And
a strange job.
And what came first, the physics and the teaching, or the acting and performing, or was it a
I
natural?
don't know. When I was young, I was very curious. A lot of questions to my father. So, physicist is this. So, and juggler is arrived 20 years old, so late, and I started performing in this time. So it's 25 years that I perform on stage as juggler before, now as disseminator.
Yes.
Yes.
And are you based at a school, or do you sort of tour and show your talents in any different?
So I am a teacher in part-time, so I am at school 3 days, and the other days I travel for theater and not only, also in Europe with my performers. Not only juggler, juggling and physical juggling. I have a good performance on gambling and the mathematics of gambling, general relativity, special relativity, and one of global warming, the last one was bored.
Yes. Well, fantastic. Well,
Yeah.
one more time, it's a big round of applause for Federico.